Hi students, in this video we will be solving question number 14 from the exercise 10.4 and this is the first PU syllabus. You go to playlist and look for straight lines. In that folder you will be able to find all the sums and derivations related to this chapter. Students, I want to communicate something. When you have some doubt, I ask you to put it in the comment section. But when you put your doubt in the comment section, be very specific about your doubt. If the video is of 30 minutes, then it will be very difficult for me to watch the video for 30 minutes and then check where is your doubt. So be specifically mention the time at which you have doubt and mention the question number also. Then it would be easy for me to check and reply back. So let's check question number 14. Find the coordinates of foot of the perpendicular from the point -1, 3 to the line 3x minus 4y minus 16 is equal to 0. So there is a line 3x minus 4y minus 16 is equal to 0 which has a perpendicular from the point -1, 3 and we have to find the coordinates of foot of the perpendicular. So what is foot of the perpendicular? Let's say there is a line which is 3x minus 4y minus 16 is equal to 0. So this is the line. Now from the point -1, 3 there is a perpendicular which is dropped onto this line. Okay. The perpendicular which is dropped, the foot of this dropped perpendicular to the line lies on the line or this point of intersection of this perpendicular and this line is foot of the perpendicular. Is this clear, students? So this is the foot of the perpendicular. So we have to find the coordinates of this foot of the perpendicular. So we have to find the coordinates of this point which is the point of intersection of these two lines. And this point lies on this line and also on this line. So this is the point of intersection of these two lines. The coordinates of this point is what we have to find now. Okay, we know this line, we know a point on this perpendicular. Okay, with this data we have to find the coordinates. I'm calling the coordinates of this point as a, b. So this sum can be solved in two different ways. I'm showing you one of the methods. That method is very easy. I will just explain at the end of the video. Please watch the video completely. So let us write the data first. Let us consider the coordinates of foot of the perpendicular from -1, 3 to the line 3x minus 4y minus 16 is equal to 0 be a, b. So I'm taking this point, this foot of the perpendicular as a, b. And I'm calling the slope of this line as m1, that is line joining -1, 3 and a, b. Okay, now when we know 2 points on the line, we can easily find the slope of the line. What is the formula for that? Slope is equal to y2 minus y1 by x2 minus x1, right? Yes, we shall apply that formula to these 2 points, which will be b minus 3 whole divided by a plus 1. So this is the slope of this. Now we have this line. We know the equation of this line. I'm calling the slope of this line as m2. To find the slope of this line, what is that standard form? Minus b by a, right? Or if you don't remember, reduce this equation to slope intercept form. What is slope intercept form? It is y is equal to mx plus c form. Y is equal to mx plus c. So mx, so this m is 3 by 4, which is the slope of the line. Okay, I am retaining y to LHS and moving the other two terms to RHS to get this form. Clear? Yes. So slope m2 is 3 by 4. When we know that the two lines are perpendicular, definitely we will be using that condition. What is the condition of perpendicularity of two lines? It is m1 into m2 is equal to -1. So when they say that they are perpendicular lines, we are going to use that in the solution. So I'm substituting for m1 and m2 and using the condition. So m1 is b minus 3 by a plus 1 into 3 by 4 and this m2 is 3 by 4 and that's equal to -1. If you just directly calculate, what is the slope of this line? These are perpendicular lines. Slope of this line is 3 by 4. And what is slope of this perpendicular line then? It's -4 by 3, right? Yes, directly we can calculate that. So I'm retaining this term in the next slide also. Now let us simplify this. I'll multiply this. This would be 3b minus 9 whole divided by 4a plus 4, and that's equal to minus 1. You cross multiply and simplify. What we get is an equation in a and b, that is 4a plus 3b is equal to 5. I'm calling this as equation 1. Now, this A comma B, which is the foot of the perpendicular, is the point of intersection of those two perpendicular lines, right? So, it has to satisfy both the equations. So, it definitely satisfies 3x minus 4y is equal to 16. This is the equation given in the sum. It has to satisfy that equation. So, I am substituting A comma B in this equation. Then, 3a minus 4b is equal to 16 is what we get. I am calling this as equation 2. See, we have two linear equations. If we solve these two linear equations, we get A comma B, right? This you would have already learnt in your high school. Solving these two linear equations gives us A comma B. A comma B are the values which satisfies both equations 1 and 2. Do you agree? Yes, it satisfies both the equations. Now we shall solve for A and B to get the coordinates of the foot of the perpendicular. Now, to solve equation 1 and 2, I am writing both the equations. Let us make this term same by multiplying 3 to this whole equation and multiplying 4 to this whole equation. By doing that, we will be making these two terms as 12a, right? Yes. So, it is 12a plus 9b is equal to 15 after multiplying by 3. Then the second equation will be 12a minus 16b is equal to 64. Now, when we subtract these two equations, we can get rid of this 12a and we can get the value of b. I have retained those two equations with the change in the sign because we are subtracting. I have changed the sign here. So it was positive, it has become negative. This was negative, it has become positive. Again, this positive term has become negative. Now we will subtract. This gets cancelled. Then it will be 25b is equal to minus 49. So b will be minus 49 by 25. So we have got the y coordinate of this foot of the perpendicular. Now if we substitute this value of b, any one of the equations, the initial ones, let us do it for the initial ones. You can substitute in any one of these two equations also, but the number will be bigger and simplification takes time. Instead, you consider equation 1 or equation 2 and substitute the value of b in it. Then I have considered 4a plus 3b is equal to 5. You can go for any of the equations. Then 4a plus 3 into minus 49 by 25 is equal to 5. This will be 4a is equal to 5 plus, when we multiply this 49 into 3, what we get is 147, and this by 25 as it is, and this becomes a positive term. Then take LCM and simplify. 4a is equal to 125 plus 147 by 25. You add these two, we get 272 by 25. Now this is 4a. What we get for a is 272 by 25 into 4. This, when we simplify, this 4 ones are 468s are when we simplified. So the value of a will be 68 by 25. We have got the coordinates of the foot of the perpendicular. X coordinate is 68 by 25 and y coordinate is minus 49 by 25. So the coordinates of the foot of the perpendicular is 68 by 25 comma minus 49 by 25. Okay. Hope you have understood this now. Now let us understand the second method. We can easily find the slope of this line, which is m2 is 3 by 4. Now slope of this perpendicular line, after using this condition m1 into m2 is equal to minus 1. When you use this condition, we get the slope of this perpendicular as minus 4 by 3. This is 3 by 4. Slope of the perpendicular will be minus 4 by 3 using this condition. Minus with the reciprocal. Okay. So it is minus 4 by 3. We know a point on the line. We also know the slope of this line. We can easily find the equation of the line. Correct? You know the equation of this line and you also know this equation of the line now. You have two linear equations. Solve for x and y using these two linear equations. This is equation of this and equation of this after finding the equation. then what x and y we get is nothing but the point which satisfies both the equations, or the point which lies on both the equations. So it will be the coordinates of the foot of the perpendicular. Is it clear, students? Yes. If you still have any doubt, please do mention it in the comment section, but be very specific about your doubt